All right, we're good. Now, hey, everybody, welcome. I am not obviously here today. So what I like to do for our lessons is at least give you the opportunity to see me in action and be able to get you up and moving. So this is on the blog, and we'll go through what we're going to cover today, give you a chance to work. Assignment's a little shorter than what's anticipated, so I know you're all smiling right now. All right, here we go. Here's what we're going to accomplish today. As you know, we did the aerobics yesterday. We got to get stretched out, get ready to go for class. We'll check the assignment. It is on the blog already. I know this class didn't get your quiz back, and I know you'd like to see it. If you have any issues, just see me on Wednesday. We'll turn those back in. Do not leave with those quizzes, please. We're going to talk about graphing linear inequalities, which you know how to do. We're going to combine our inequality knowledge and our graphing, and then we're going to introduce graphing and solving some equations. Basically, a system is more than one equation. Okay? So, a little review of yesterday. We talked about shifting right or left. The mathematical term for that, I don't like to use mathematical terms very much, but the mathematical term, just so you know, is translate. So we're translating if we're moving left or right, up or down. Okay? I didn't put up or down, but it is. If you're getting fatter or skinnier, we talked about what causes that. That's a transformation. Sort of like Transformers. They go from a truck to some robot. They change. They get a different form. So transforming is fatter and skinnier. Okay? So you know what? It's about time to get our exercise on. So get on up. No, seriously. Get on up. Everybody, even you couch people, get up. Come on. Get on up. All right. Here we are. We're going to start with y equals 5 absolute value x. Okay? Here we go. Ready? 5 absolute value x. Remember, we're going to be skinnier. Skinnier. Okay? Next one. Negative 5 absolute value x. Ready? Negative. Down, then skinny. Look at that. I look thinner already. Okay, number 3. Let's go to 1/4 absolute value x. Ready? Get your fat on. Okay, and negative, palms down, palms down. Boy, if you're not stretched out by now, you will here in a second. Okay? All right, here we go. Now we're going to start translating, moving right or left, up, down, translating. Y equals absolute value of x plus 2. Okay, so we're here. And now we are going to move to the, is it right or left, right or left, right or left? Plus 2 would be to the right. So I guess I better move to the, I guess it's left for you, it's right for me. So we're moving this way. I always get confused. So boom, boom. Okay? X minus 2, same thing, opposite direction. To your right, my left, since I'm facing you. All right? Now, let's put it all together. Put it all together. Go one step at a time. Okay? Decide. With the negative 2, we're going to be opening downward, palms down. Are we going to be fatter or skinnier? In this case, a little bit skinnier. Now we're going to shift. Shift. So to your right, and then minus 2, drop it. There's our aerobics. Get your stretch right here. Really feel it burn. Feel it burn. All right, last one. Negative, absolute value of x plus 1, plus 1. Here we go. This one's a little bit difficult. We're down. Plus 1 means we're moving to the left. My right, your left. 1, and then we got to go up. 1. Please no standing on the desks. None of them are really that stable. So we're up. Get on those tippy toes. Feel it burn. Calves. Oh, yeah. There you go. All right. Now, with that, you should have a basic idea of your movement. When you went to your homework last night, a lot of you used the graphing calculators. Did you need them? No. This is the movement of your vertex. Remember our vertex with the parent or the generic is at 0, 0. So this moves your vertex. In this case, we move to the right 2 and down 1. There's my new vertex. And then I could have sketched this. Negative 2 is going to be a little bit skinnier. Is it perfect? No. I could throw it in my graphing calculator, go to table, and I could come up with some ordered pairs. I could do that. Or I could just punch in some numbers here and figure it out mathematically. I need you to have a basic understanding of how to draw this, a sketch of it. All right? So, stop the video right now and go to the blog and check your assignment. Okay? We're going to keep going, so make sure you hit pause on this. Okay? All right. Hopefully you got your assignment checked. We'll go ahead and collect those. We might as well. Now, while you're checking your assignment, hopefully you got your quiz back. We'll have to turn on the screen and the projector there. The quiz is sitting there, so if somebody could help out, if our wonderful substitute doesn't know how, then just help out. Put the quiz answers up. If you didn't take the quiz, don't sit in here, dorks. Get out. I can check real quick. I'll check here in a moment to see, or I'll have names up of people that need to be gone. Those names will be up here after I'm done with this. All right, graphing linear inequalities. We're going to move on. Can you graph an equation? Let's take a little review here. Graph an equation. Remember, here's my vertical start. Performance here. Down 2 over 1. Connect the dots. La, la, la. Any problems? Y equals 4. Horizontal or vertical? How did you remember it? Horizontal. Through the y-axis. There it is. X equals negative 2. That's a vertical line. Through negative 2. Now this, there was 2 ways. We could rearrange it. Throw that over. Divide by 5. That's one way. Or you could just pick 2 points. Remember we talked about the intercepts. It doesn't have to be the intercepts, but those are the easy ones. Put a 0 in for x, it basically disappears. So y is 2. Put a 0 in for y, and x is 2x equals 10. What times 2 equals 10? 5. Either way is fine with me. I don't care. I'm going to go ahead and just use this one. Down 2 over 5. If I chose that one, 0, 2, 5, 0. It's nice. Any problems? When you get this last one, you think, oh, geez, I got decimals. It's not a big deal. I'm going to go ahead and put it into slope-intercept form. Slope-intercept form. When I divide 2 divided by 1.5, oh boy, I don't even know what that is. 2 over 3/2. 2 divided by 3/2. That's the same as that. Dividing is the same as multiplying by the reciprocal. So it's 4/3 x, and it would be negative. Okay. So we can do that. Negative 2, down 1, 2, 3, 4 over 1, 2, 3. Connect the dots. Hopefully that is a huge review. We did 5 problems in 2 minutes. Now what we're going to do is, can you graph an equation? I hope you can say yes. We're going to graph a linear inequality. Remember, when you hear inequality in line, we're solving. When do you flip your inequality? When do you flip it? Quick review. 8 is greater than 4. But if I divide by negative 2, I have to flip it. So anytime you multiply or divide by a negative, you got to flip it. Okay? So what we're going to be working with is linear inequalities. So now this was a linear equation because of the equal sign. What we're going to do is make it an inequality. We're going to make it an inequality. We're going to make it an inequality. We're going to make it an inequality. What did I go with there? All right. And an inequality. Okay? So, what's the difference? What we did when it was an equation was we created a boundary line. A boundary line, everything is the same. You're going to treat it just like it's an equal sign, and that creates your boundary line. Then we have to decide if it's solid or dotted. Now take a moment. What would you guess? Remember when we graphed x is greater than 4 on a number line? We'd put 4, and did we put an open circle or closed? In this case, it's open because we are not including it. Not including it. And then we went to the shading. Anytime you have an inequality symbol, you're going to do some coloring. Greater than or equal to. So we are including. Remember, with an equal to, we include it. So guess what? Solid or dotted boundary lines. If you have a greater than or equal to, we are going to be solid. If you have a less than or a greater than with no equal, we are going to go dotted. So all I'm going to do is do some dotted lines. Here I would go solid. Here I would go dotted. Here I would go dotted. So I made that decision. That's pretty simple. Kids forget it a lot. But if we have a solid line underneath, we're going to have a solid line. Simple way to remember it. Now the last part is we're talking about all ordered pairs that will work for this equation. Every one of them. Every one in the world. All y values that are less than 4. Well, all the y values less than 4 are right here. Every one of them. This has got a y value less than 4. Every dot out here. So that's where we talk about shading. So y values less than 4. We're going to shade those values that would be included. X values less than or equal to 2. We have a solid line. The smaller values than negative 2 are on this side. Now the question comes up when we have an equation written in slope-intercept form. I'll show you two ways. Number one, if you are in slope-intercept form and it says y is greater than, you're going to shade the side of the bigger or on top of the line. So over here for sure. That's one way. Here we have, it is not in slope-intercept form, but we've created it into slope-intercept form. Now it says y is greater than. I'd shade above it, greater than. The other way is to actually pick a point. Pick an ordered pair. The most famous ordered pair to pick is 0, 0. There it is. And plug it into the equation. Whether you plug it in here or here, I would plug it into the original. 0, the ordered pair is 0. That means the x value is 0. What's 2 times 0? 0. The y value is 0 also. What's 5 times 0? 0 plus 0. Is it greater than 10? If the answer is yes, you would shade in that side that includes 0, 0. In this case, 0, 0 is not greater than 10. So we would shade in the other side. Let's come over here to this last one. Now, the reason I left this out is because we had to remember back to step 1. When to flip it. I added the 2x, and now I should divide it by a negative 1.5 here. When I do that to both sides, I need to flip my inequality. Okay? Now the question comes up, which side should I shade? In this case, it's less than. Y is less than. So less than would be shade it below. This is where I'm going to end up shading. If I want to double check, pick the ordered pair 0, 0. Plug it in. Negative 1.5 times 0 is 0 minus 2 times 0. Is 0 minus 0 greater than 3? The answer is no. So I would not shade in the side that includes 0, 0. Okay? Now the assignment's on the blog, I believe. If it isn't, I got it right here. It's page 135. Hello? 135, 18 to 18, or 8 to 18 evens, 31 to 36. So I'll give you a few minutes to get that going, and then we'll turn this back on and talk about graphing systems. You can